In this video, we're going to look at two more examples on how to graph ellipses and identify the center, the vertices, the foci, the length of the major and minor axes. So what I want to do here is look at my first example, x minus 3 squared over 9 plus y plus 5 squared over 4 equals 1. This is already in my standard form. What I'm going to do now is I'm going to identify just by looking at it whether it's a vertical or horizontal ellipse. And I could do that by looking at the largest denominator. So my largest denominator is 9, and that is located under the x. And so what that tells me is the ellipse will be stretched more along the x-axis than it is the y-axis, which means this is a horizontal ellipse. Now that allows me, if I'm going to use my formulas, it tells me which formulas to use. And we know that I prefer to learn the concepts, not just the formulas for it. So the first thing I want to do is I want to identify the coordinate of my center. And we do that by looking at our h, k values. So here h is 3, and here k is -5. So that means my center is located at the coordinate 3, -5. So I'm going to plot that first, 3, -5. And now I go for my vertices. Now, if you want to use the formula for the vertices, you can. I prefer to learn the concepts. And what you do is you find your a value. So a squared is 9, which means a is 3. And you find your b value. B squared is 4, which means b is 2. Remember, a represents the distance from the center left and right to the vertices. And b represents the distance from the center up and down to the vertices. And so what that means is instead of using the formulas, I can just count on the graph. I can go right 1, 2, 3 units. There's one of the vertices. Go left 1, 2, 3 units. There's another one. Now I'm going to use my b value by going up 1, 2 units and going down 1, 2 units. There you go. They're already graphed. And now I can actually state my points by looking at the graph. You have the coordinates 6, -5, and 0, -5. You have the coordinate 3, -3, and 3, -7. Now, if you wanted to use the formulas, you would do h plus or minus a, comma k, and you would do h, comma k plus or minus b, and that should yield the same results. And if you look at what I did is I went left and right 8 units. Well, that's adding and subtracting from your h. I went up and down b units. That's adding and subtracting from your k. So I did use the formulas, but I used them visually instead of algebraically. And so now what I want to do is I want to find the coordinates of my foci. Now the foci are located c units from the center along the major axes, which we said in the beginning is horizontal. To find c, you're going to have to use your c squared formula, which here we just said in general rule is do the larger minus the smaller. So it's going to be a squared minus b squared. So c squared, we have 9 minus 4. That means c squared is 5. So c equals the square root of 5, which is approximately 2.24. So your foci are located c units from the center along the major axes. So the formula we have here is h plus or minus c, comma k. I prefer, for me, the way I work, to use the radicals. I would go from my h left and right radical 5 units. So my h is 3. So then I would go 3 units to the right. So that's 3 plus radical 5, comma -5. And I would go 3 units from 3 to the left, negative radical 5. So I have 3 minus radical 5, comma negative 5. I prefer to write it in the radical form. But then you may ask, well, how do you graph that? I mean, Mr. Ransberg, you don't know what this decimal place is. Well, no, I know the exact location is this. The approximation I can't tell from this, but I do know that radical 5 is 2.24. So from my center, I go 2.24 units to the right. There we go. I go 2.24 units to the left. And there you go. And so I can use this approximation to count left and right to get the coordinates on the graph. Now, if you wanted to use the formula itself, I'll do this in a different color for us so we can actually see it. And we'll do the black since we're going to use the formula. We would do h, which is 3, plus 2.24, comma negative 5, which that would give me 5.24, negative 5. And we can see that's about where I'm at, 5.24, negative 5. And I would do 3 minus 2.24, negative 5, which would be 0.76, negative 5. And we can see that's about where I'm at as well. So both techniques work using the decimal approximation or just using the radical and going from there. I don't care which one you use. We know which one I prefer. And then I would graph with my ellipse on here, so I don't forget that. So graph with the ellipse, making sure we go through all the points. Now I am using the computer, so I have to drag mine up to get to where it needs to be. You just go through and connect with an elliptical shape. You would say an oval shape. And I still have left the finding the length of the major axis, the minor axis. Now this is not hard. The major axes, from the center, we went right 3 units and left 3 units. So twice 3 would be 6. The length of the minor axes, we went up 2 units and down 2 units. So twice 2 is 4. And so the length of the major axis is 6 units. The length of the minor axis is 4 units. I have the coordinate of my center, of my vertices, and of my foci with the decimal approximations in case you needed them. And I have the length of major axis and minor axis along with my graph itself. So let's look at the next example. Again, this is already in standard form for us. So what our job is to do is to identify our h, k, a, b, and c values. And from there, we can graph it. So here, h is negative 4, k is 2. That tells me my center is located at the coordinate negative 4, 2. And so negative 4, 2, plot the point. Looking at this, I see my larger denominator is underneath the y. That tells me this is a vertical ellipse. That allows me, if I'm going to use the formulas, to know which ones to look at. A squared is 25, which means a is 5. B squared is 36, which means b is 6. So I like to just use the definition of what a and b are. A is the distance along your horizontal to the vertices. So I'm going to go right 1, 2, 3, 4, 5 units. I'm going to go left 1, 2, 3, 4, and I'm going to go off a little bit to go 5 units to the left. B is 6, go up 1, 2, 3, 4, 5, 6. And go down 1, 2, 3, 4, 5, 6. And there are all my vertices. The coordinates then, if I do my horizontal first, I'm at negative 9, 2, and 1, 2. For the vertical ones, I'm at negative 4, 8, and negative 4, negative 4. So now let's find, so we have our center, our vertices, let's find the coordinates of our foci. So for this one, we do c squared, larger minus smaller of the denominators, so that'd be b squared minus a squared. So that's 36 minus 25, so c squared equals 11, which means c is the square root of 11. Remember, C represents the distance from the center to the coordinates of the foci along the major axes. So for here, my C are going to go up and down. Square root of 11 is approximately 3.32. Again, I like to just use the radical. Since I'm going up and down, it'd be negative 4 comma 2 plus square root of 11 and negative 4 comma 2 minus the square root of 11. Those would be the exact coordinates, and I can count up and down 3.32 units. So 1, 2, 3.32, approximate it, go down 1, 2, 3.32, and approximate it. There are my foci. If you want to use the formula, it was h comma k plus or minus c to get the coordinates. So my h doesn't change, it's negative 4, and I would do my k value, which is 2, plus 3.32, which gives me negative 4 comma 5.32, and I would do negative 4 comma 2 minus 3.32. And so when you do that, you get negative 1.32. So negative 4 comma negative 1.32. And you see that is close to where I already marked my foci. So let's connect it with our ellipse. And again, I just graph mine with the computer, but you would go from vertex to vertex, connecting with an elliptical shape or a U shape for it. And so there is my ellipse. I still have left finding the length of the major axes and the minor axes. Our major axes here, we went up and down. Our vertical was our major, so we went up and down 6 units, so twice 6 is 12. We went up and down 6, so I do 2 times 6. For our minor, we went left and right 5, so I do 2 times 5, which is 10. So length of the major axis is 12, the length of the minor axis is 10. So I hope you found this video helpful. Again, if you want to use the formulas, go use the formulas. But understand the concepts because it's quicker to actually graph and state the coordinates for them.